गुड मॉर्निंग स्टूडेंट्स. गुड मॉर्निंग बच्चों, ऑल ऑफ यू. कैसे हैं आप सब लोग? मस्त, एकदम मस्त. ओके, आई एम योर गाइड, केमिस्ट्री लेक्चर सीके से. ओके, in the last class we have started with the Nernst equation. We derived the Nernst equation for a half cell and another one is a Daniell cell. Okay, we introduced Nernst. Okay, we are derived the expression for the first one is for half cell, that is nothing but single electrode potential, and later for a single electrode, and later we are going for the Daniell cell. Okay, in this class also we are continuation with the Nernst equation only, but in this class we are using Nernst equation for the what? Tell me, standard hydrogen electrode. Okay, standard hydrogen electrode nothing but for a sheet. If we are going to use Nernst equation for sheet, what's going to be happening? Let's see. Okay, before of this, I will write the expression one more time for single electrode potential. Okay, for single electrode potential, that is the reduction. Okay, single electrode potential, half cell. Okay, Nernst equation. Okay, Nernst equation for half cell. What are the expression for this one? Okay, I am writing here. The first one is the reaction is going to be undergoing the reduction m plus n moles of electrons is gives rise to m. This is a solid part. Okay, and later we are going for the writing the Nernst equation. This is E of cell, or we can write here the whatever the expression. Okay, n plus m is equals to, okay, standard electrode potential E naught mn plus divided by m minus 0.0591 divided by n, a log of here what 1 divided by m n plus. Instead I can write m also. M is nothing but metal, that's why I am taking metal is a m. I am considering 1. Okay, this is for what? A single electrode or half cell. This is a half cell reaction. Now if I am writing for the Daniell cell, okay, for the Daniell cell, the equation will be for Daniell cell or galvanic cell, E of, okay, Cu plus 2, I can orally I can write down here E cell is equals to, okay, E naught cell minus 0.0591 divided by n, okay, a log of Zn2 plus divided by Cu2 plus. This is the expression for the Daniell cell. If I am going to be writing the Nernst equation for the single electrode potential or one single half shell or half shell, this is become the reaction. I consider the equation will be the reduction equation. Okay, at a cathode this is, okay, at a cathode this reaction is happened. If I am writing the Nernst equation, this is the Nernst equation for the half cell, and this is a Daniell cell. Sir, what is this Daniell cell? These are having the two half cells. Okay, combining of two half cells, it is going to be forming the one complete cell. This is Daniell cell, this is a single. Okay, this is half cell. Now today we are learning about the very important concept, that is Nernst equation. Okay, if I am going to be applying Nernst equation for sheet, that is standard hydrogen electrode. Okay, see, when we are writing for the Daniell cell, now I wanted to write the Nernst equation for the sheet. Okay, already you people know what is the reaction is happening at the sheet, standard hydrogen electrode. Here also I am considering it a cathode, because in the sheet the oxidation also possible, reduction also possible. Okay, redox reactions are going to be take place in the where sheet, but I am considering only cathode. Okay, because cathode is a very measurable for the Nernst equation. See what happens, 2H plus, actually reaction what happens, 2H plus plus, okay, 2 electrons is gives rise to H2. Okay, this is a reaction. Okay, now I wanted to write equation, okay, the standard Nernst equation for this reaction. Write down E of, okay, take down H plus H2 gives rise to E naught of H plus H2 minus 0.0591 divided by n. What I can take for n? What is the n value? 2 electrons. Okay, here will be the 2 electrons. First I will write formula, later we are going to take the values. Log of here, this is will be the H2. Okay, here will be the H plus. Okay, H plus. See all of you, this 2 nothing but this is a going at the power. Okay, इधर H2 है बोले तो ये power पे जाता है. H2 H1 square. Okay, H1 the power of 2. Okay, see all of you listen carefully. This H2 is comes at this top. Okay, जो भी moles, number of moles, 2 moles of H plus ions. This 2 mole I am taking at the power. Okay, now I am writing here. This is what standard hydrogen. Okay, this is the standard electrode potential of She. Standard electrode potential of She is what? 0. Okay, directly I can write 0. What is the now equation? E of H plus H2 is gives rise to, this is completely 0 minus 0.0591 divided by n. I can write as a 2. This value is 2 because number of electrons are revolving is 2. And next on log. Okay, log H2 is gas limits. I can take this as a 1 and H plus the power is 2. The power is 2. Okay, this is what simple expression first. Now reduce this one. E of H plus H2 gives rise to this is what minus 0.0591 divided by 2 log of. If I am going to be taking this H plus into the denominator, okay, this is denominator, I am taking the numerator. Okay, what happens? Let's see here. इसका फॉर्म में ये आता है, देखो H plus whole power 2 is there. When it's coming upper side, H plus this power will be minus 2. I am writing this same expression. Okay, I can write here H plus minus 2. Okay. In one more we are having the condition is that I told you in the last class, log of a power b nothing but b log a. I can write this is in the form of log a power b. Okay, a in the sense H plus, b in the sense minus 2. I am writing now. See what happened. See here minus 0.0591 divided by 2. What I can write? B. Okay, log a power b in the sense log a power b को क्या लिखते हैं? B nothing but now minus 2. I am writing here according to the formula minus 2 and log. Now what happens? H plus. Okay, this is the H plus. What happens? See all of you now. This is minus 2 get cancelled. This minus and this minus became plus. Now what happened? 0.0591 or log of H plus. This is the value. Okay, this is value I am going to be getting. Okay, log H plus. See, this is now positive value. I can also make this one as 0.0591. Okay, minus. I can also write like, okay, and minus log of H plus. Okay, minus log of H plus. In the standard, the value of listen carefully, minus log H plus, I can write this as a pH value. One of very important. Okay, I can write this as a pH. So now I am writing here जो भी माइनस है माइनस रखो 0.591. Whatever minus log of H plus will be there, consider that as only pH. That is nothing but pH. Okay, this is what the final expression what I can write for the Nernst equation for the sheet. This is what a Nernst equation for sheet. Okay, what we are done, just we are applied we are taken first reaction is a cathodic reaction. After the cathodic reaction, what happens here? This is commonly I can say this is EH plus nothing but E cell. Okay, E cell. This is E cell. I can write this is also or E cell because we are finding for this cell potential of the standard hydrogen electrode, nothing but She. Okay, E cell R. I can write E of H plus H2. The standard electrode potential for the She in terms of Nernst equation is I can reduce to this one. Okay, this is nothing but minus 0.0591 pH. Okay, this is about what how we can going to be deriving or we can going to be expressing the sheet in terms of Nernst equation. Okay, now take down first. After this one, we are going for the problematic section where we are going to be deriving. First, we are derived already the half shell, and we take some problems on the half shell, and later we do some problem on the Nernst equation, and later we are moving towards the equilibrium constant. The Nernst equation in equilibrium constant. Today, one by one, we are going to be dealing. Okay, take first this one or take screenshot first. 1, 2, okay, 3 over. Now we are seeing the problems. Okay, we'll solve one by one problems. Okay, problems are very important for the your theory examination as well as the NEET concepts also, because this year also the direct question is asked from the problematic section. Okay, based on this Nernst equation. See, first one, a zinc rod. The first question is, it is the base of a single electrode or only half cell. Okay, what is half cell? We are having, okay, in a one cell we are having two half cells. Like in a, for example, Daniel cell, we are having the two half cells. One is cathode, another one is anode. In this case, in this problem, especially we are going to be taking only the half cell, only one side. Okay, see here, what happening? A zinc rod is dipped in. Okay, a zinc rod is dipped in 0.095 molar solution. Okay, of zinc sulfate at 298 Kelvin. Okay, in the sense the problem states that a zinc rod is there. First of all, make a zinc rod. Okay, before going to be the solve any problem, you have to make some conceptual or the pictorial representation. It's very helpful. This is a zinc electrode. All of you know this is zinc electrode. This is a dipped in. Okay, he is telling that the zinc rod is dipped in something will be there. Okay, that is nothing but this is dipped in 0.095 molar solution of zinc sulfate. Nothing but ये अंदर क्या है बेटा? This is a electrolyte. This is electrolyte. Okay, this is a electrolyte. Right here, this is electrolyte. Okay, कौन सा electrolyte है? Almost we are having zinc sulfate. He is given also zinc sulfate. The concentration is how much? 0.095. Okay, 0.095 molarity. Okay, now at a temperature also is given at temperature 298 Kelvin. He is given calculate the electrode potential. Okay, electrode potential of zinc electrode. In the sense, he is asking what for us? E Zn plus 2 Zn. Okay, electrode potential, and he is given the standard electrode potential. Nothing but he is given what? E naught of Zn plus 2 Zn is equals to minus 0.76. He is given this one. Okay, minus 0.76. He is given this value. Now he wanted to ask the what? Electrode potential. Okay, what is the electrode? We are having according to the Nernst. I am writing here. According to the Nernst, he is derived one equation for the single electrode or half cell. Okay, what is that? E of, according to this I am writing E Zn plus 2 Zn gives rise to E naught of Zn plus 2 Zn minus 0.0591 divided by n log of, here Zn nothing but I have to take 1 because zinc is a metal. Okay, I am writing here directly 1 divided by the whatever the I am having Zn plus 2 answer. Zn 2 plus. This is a what a simple representation. What I can write. Okay, if we are going to be practicing the Nernst equation, you will come to know very nicely. Okay, because here I have to write here Zn. I am writing only Zn, only 1 because instead of Zn I have written 1 because Zn is a metal. Okay, now I am going to be substituting the values. What are the values I know here? All of you see this is Zn plus 2. This is value is known because he is given. Okay, standard value. And n value also now I know because n is nothing but number of moles of electron. 2 electrons are going to be Zn plus 2, Zn plus 2, Zn plus 2. Okay, wherever Zn, there are 2 electrons. N nothing but 2 electrons. And he is given the concentration of Zn also. Okay, he is given the concentration of this one also. Now we are going to be calculating the one by one. See, first I wanted to calculate this one. Yeah, Zn plus 2, Zn gives rise to what is value is given? Standard minus 0.76 0.76 minus 0.0591 divided by 2 log of, also is given here what, the concentration, that is what, 0.095. okay, write down 0.095, write clearly 95. okay, this is what we are all taken the, what is given, okay, given. Now what happened, now I am going to be calculating this one, okay. See, log of 0.095, okay, log of 0.095, I am going to be dividing this one, 1 divided by 0.095, what is the value? All of you tell me, what is the value? Minus 0.076 divide, first of all take this one, okay, take this, write this one as it is. 0.0591 divided by 2, what happens? 0.059 divided by 2, that is value is 0.2955, just divide this one, okay, इसमें कुछ भी नहीं है, इससे इसको डिवाइड कर दो, log of, write down this value, what happens? Log 1 divided by 0.095, make it calcifos, okay. One more important thing, you are only allowing in theory examinations only the simple calc, okay. Do this one more, 10.562, okay, 10.562, okay, value will be 10.562. Now what happens, okay, here see, we are got the first value is minus 0.076 and minus when we dividing here with this value, and 1 divided by this one will be this much. Now so many students know what is the log 10 value, okay, what is the log 10 value? Can anyone? 1 point something, because log 10 base 10 is 1 almost, okay. We are having 5.6 nothing, but will come 0.24 something will come. Now see what I am going to be doing now, 0.076 minus 0.02955, a log, it will be log now. Now what I can write for this log? Log 10.562 value will be 1, okay, that is exactly 1, okay, 1.0244, okay. Log 10 base 10 nothing but almost 1, this is having some bit greater than, and considering already we are studied this logarithms in our bridge course also. Now see 0.244, this is value, okay. Log 10.562 value is 1.024. Now do the calculation, what we are going to be getting, minus 0.076 minus multiply this both to, what we will get, 0.3021, 0.3021, okay na, 0.0. Now add this one, what we are going to be getting, minus into minus, okay, this is minus, add up this both to and give the sign as negative, okay. Take this 0 point, okay, again 0, we are having next what, 0.7, add this one, okay, 0 0 8 3 इधर है, 7 3 7 9, okay, this 6 plus 3 is 9 9 2 1 4, okay. This is about what you are electrode potential of the zinc, whatever the electrode potential of zinc will be there, ammeter this one, okay, Zn plus 2 Zn, okay. Whenever this is your final value, okay, this is in terms of volt or base. See here what happening, first he is given a problem based on the single electrode potential of half cell, okay. A zinc rod is dipped in, one zinc rod will be there, that is I am going to be dipping this solution having zinc sulfate, and that concentration will be 0.095, and you wanted to calculate as electrode potential, bolute, whenever I am going to be dipping inside, this is having water, it will liberate Z plus ions, okay, Z plus ions, nothing but tendency to liberate the electrons, okay, dissolution होता है, okay, solution में Zn plus ion increase होता है, that time what happens, a potential difference is going to be developed in between this electrolyte and this electrode, that potential is going to be created, that is how much potential is going to be causing, that potential will be 0.7921 volts. Sir हम कैसे करें बेटा, बहुत simple, first I taken this as a Nernst equation, standard one, I am representing Nernst equation according to this half cell, okay, Zn Ezn plus to Zn, this is standard electrode potential minus we are having this expression. Okay, just conversion we have to remember, we have to keep in mind that just how to write here. Okay, I am only taken for this one जिंक Zn plus. सर इधर जिंक आता था, किधर गया? जिंक मेटल है, that's why I am not taking Zn. Okay, again I substituted all this value. N is I know very well because 2 electrons, and this also the whatever Zn plus 2 concentration is already given in this question. Okay, this question 0.09. I substituted and I enter the operate the calcium and get the result. This is what a problems on single electrode potential. Now, if a problem is going to be arising on the double cells, okay, what's going to be happening when us instead of single cells he is going to be giving double cells? Nothing will be happening. Okay, let take the next problem, that is calculate EMF of cell for given different concentration terms. Okay, suppose we are having already, we come to know that EMF cell for given different concentration terms in two concentration terms are given, nothing but there should be two cells, there should be two half cells, nothing but a cell is going to be formed. This is a water, this is a, for example, this is instead galvanic cell because the anode is zinc and cathode is the copper. Now we are going to be solving the problem for this one. Okay, see here, first what I am going to be taking, I am having two containers. Here two electrodes are going to be taken. One is a zinc, another one is a, this is a zinc, this is a copper. Okay, here zinc sulfate will be there, here copper sulfate will be there. Okay, I am consider just pictorial representation. Now what we want to take, we want to sell the E cell. Okay, EMF of cell, he wanted to calculate as EMF of cell, nothing but Cu plus 2 divided by Zn plus 2. How much value? Okay, just he is given what molar concentration of these two things. Again come to the realistic, what we have to do, first take what we have to take first take the Nernst equation, because Nernst equation itself tells that whenever, okay, जब भी unit molar concentration नहीं रहा तो electrode potential unit molar concentration नहीं रहा तो we have to use the Nernst equation, then what is that Nernst equation, sir? Let's see. Okay, how we are going to be representing Nernst equation for this? Okay, these are having two electrodes, okay, copper and zinc. E of Cu plus 2 Zn plus 2 equals to E naught of Cu, or you can write a 2 plus. Okay, now some reference books is going to write in 2 plus or 2 plus. Okay, plus 2 or 2 plus, whatever. Zn 2 plus minus 0.0591 divided by n log of Zn plus Zn 2 plus Cu 2 plus. Okay, this is what your expression. Okay, this is what your expression. What I have to insert here the values. Okay, already you know the standard electrode potential of the Daniell cell. Okay, the standard, because the zinc is coming, the copper is coming in that particular cell, nothing but that is a Daniell cell. Okay, I am writing here on point. Note, this is belongs to standard electrode potential of Daniell cell is already you know 1.2. After doing this potential difference, we are going to be getting what Zn plus 2 minus Zn. I can also write this as, see here, Cu2 plus Zn2 plus is raised to E naught of copper minus E naught of Zn2 plus Zn. I can also write like this type also, and minus 0.0591 divided by n log of Zn2 plus divided by Cu2 plus. Now it is very easy for you to write down. Okay, because already we know what is the standard electrode potential of copper, 0.34. Okay, already we studied in this electrochemical series also. This is a 0.34. Minus zinc is what, 0.76. Okay, minus again substitute 0.0591 divided by n nothing but what, 2 electrons are going to be revolving here. I can type here 2. Okay, the log is already mentioned, the concentration Zn पे कितना दिया है, 0.1 molar. And what is given about this copper? That is 0.001. Okay. Now I am having everything. Now I have to calculate for what a E cell. I can also write this as a E cell. Okay. E cell nothing but these are consisting of two half cells, copper and zinc electrode. Okay. उसमें कुछ भी दिक्कत नहीं. अभी देखो. Now what I can do for this? What is if I am going to be minus into minus positive, that is nothing but 1.1. Okay. Minus 0.0591 divided by 2. If what is the value of this one? Tell me. Okay. Let it be. Okay. Now take log. 0.1 divided by 0.001. What is the value? For this one, I will writing here 10 power. This 0.1 I can write as 10 power minus 1. Okay. I am writing here. See, 10 power minus 1 divided by this is 10 power minus 3. Okay. How we are going to be writing the decimal parts? Okay. Just I am 0.1 is to 10 power minus. Already know. Okay. 0.00 10 power minus 3. When this minus 3 is come upper side, okay, upper side nothing but see here I am writing here what happening 10 power minus 1 अगर जब भी ये ऊपर जाता है ये power m divided by a power m plus n. Okay, this is plus 3. 10 is going upper side. Now what happened? 10 power 2. 10 power 2. Right? Because plus is because 3 is bigger one. Okay, 3 ज़्यादा इसलिए plus 2. Now substitute directly now 1.1 minus 0.0591 divided by 2 log of 10 power 2. Okay, 10 power 2. Now if I am going to be writing the 10 power 2, we are having one standard formula in logarithms, that is we are studied in bridge course, log a power b, nothing but b log a. I can apply this now. This is the log a power b formula. Now what happens here? 1.1 minus 0.0591 divided by 2. I am writing here, see, 2 log. Okay, because this is log a power b, nothing but b log 10. Okay, this is b log 10. This is log basic 10. Okay, b in the sense what I can write value? B in the sense 2 log. Okay, this is 2 and this is the power, it is coming at the a. Okay, log a power b. b को मैं आगे लेके आता हूँ, log a स्टैंडर्ड फॉर्मूला. अभी देखो क्या होता है, this two get cancelled. Okay, this two get cancelled. Now what happens? 1.1 minus 0.0591 log 10. What is the standard value of log base 10? 10 is equals to 1. Okay, log 10 का value 1 हो जाता है, 1. Now what is the final answer? What is the final answer? Tell me first. 1 point. Operating calcium, tell me 1.0409 volt. 1.0590 volt. This is a what? EMF or this is a EMF or the cell potential. E cell potential. Okay, whatever the cell potential of this cell, we are going to be writing on this method. This is very simple. Okay. देखो हम क्या कर रहे हैं, वेरी सिंपल है, कुछ भी नहीं. हम क्या कर रहे हैं, फर्स्ट ऑफ ऑल we are going to be deriving or we are going to be finding EMF of this cell. For what? For a Daniel cell. Daniel cell in the sense these are having the 2 electrodes. Okay, this type of questions are very important. Okay, he is going to be giving the 2 different concentration and tell you to calculate the EMF of the cell, because the logic समझो क्या है, whenever the 2 electrodes are in a reaction, automatically there should be development of some potential. Okay, that potential is calculated by the Nernst equation. See all of you one more time. Always we are going to be deriving what first? This is a Cu plus 2 Zn plus 2. In the sense this is a cell, I can say this is E cell, cell potential, standard electrode potential minus whatever the expression. Okay, here the taking, so many students are making the mistake in here only. Okay, writing of this one. See carefully. Okay, what are the electrolyte will be there, what are the ions will be there? Zn plus 2 is upper side, Cu plus 2 downside. This is standard for Daniel cell. Okay, again he is already given the values of this one. Substitute these values. Okay, just while making the calculation, keep remember that 0.1 I can write as 10 power minus 2. This is 10 power minus 3. Whenever the a power m divided by a power n is cut, a power m plus n. Okay, it's come upper side 10 power plus, this is became plus 2. Okay, this again this log 10 power 2 is nothing but what I am going to doing, a power b nothing but b log a, b log a nothing but this 2 I have written here log 10. Okay, again 2 to get cancelled, log 10 is 1 I have written here, and minus 1.1 minus 0.0591 I am going to getting this value 1.0494. This is for a damage, the calculation of standard electrode, sorry, the calculation of electrode potential for the damage. Okay, okay, take down our next screenshot. Okay, first 1 2. Okay, now see, take the another problem. Okay, take another problem in which we are going to be having, in the last place he is going to be given two concentrations. Okay, now in this one he is given two standard electrode potential values. Okay, now how we are going to be calculating? Okay, let's see. The question is for a cell. Okay, we are having one cell which is consisting of two electrodes, two half cells. Okay, magnesium and copper, write the electrode reactions. Okay, he just given the cell representation, he asking us to write the electrode reaction and cell potential also, and cell potential, what is the cell potential values he wanted to tell, and also calculate the electrode potential or EMF of the cell at 298 Kelvin. He is asking for the cell potential also. Let's we are going to be doing first. Okay, first identify the cathode and anode. Among this, which one is cathode, which one is anode? He is given first two electrode. Take the diagrams. One is cathode, definitely. Another one is anode. Okay. By comparing this electrode potential values, here the anode will be magnesium. Okay, because anode is having lesser value. Cathode is this is copper. Okay, this is a different respective solution. This is a magnesium sulfate. This is a copper sulfate. Now what happens? Oxidation reduction is going to take place at anode. I am writing here at anode. Oxidation takes place. Mg gives rise to Mg 2 plus 2 electrons, and this molar concentration of this one will be Mg will be how much? 0.01 molar plus 2 electrons. For at a cathode, what happening? At a cathode, Cu2 plus, what is concentration? 1 molar plus 2 electrons is gives rise to copper. This is solid. This is also solid. Now he's telling us to write the electrode reactions. Exactly what's going to be. I am writing the electrode reactions here. Electrode reactions. See, first of all, what I am going to be writing here. Electrode reactions nothing but write out the this cancel this two electrons and write magnesium plus Cu2 plus 1 molar, it gives rise to, write on the right side, left hand side you have to write in the left hand, right hand side you have to write in the right hand. Okay, so many students are get confusing here. Okay, जो भी electron ray cancel करो, जो भी left है वो left में लिखो, right में जो भी right में लिखो. Okay, Mg plus 2 plus, this is 0.01 mole and the 1 mole is Cu. This is solid. Okay, this is what a electrode reaction. What exact what's going to be happening there? Okay, these reactions are going to be taken nothing but at anode oxidation take place, at cathode reduction. This is totally a redox-redox equation. Okay, this is a redox-redox equation. Now, what is given in the exam? In this one, see standard electrode potential. E naught for Mg is given. That is value is minus 2.37, and one more value for this one. Copper is given what? E naught of Cu2 plus Cu is gives us to 0.34. This is positive. Okay, positive 0.34. Now what? This is a cell representation. This is cell representation. According to that, we are written the electrode reaction. Now calculate the E cell. This is a very important. How we are going to be calculating the EMF of cell? Write first standard equation for us, that is E cell equals to, E cell nothing but what we wanted to calculate electrode potential. E cell is equals to E naught cell. Instead of E naught cell, I am going to be writing what? First I will write, later we will go for the deep explanation. E naught cell minus 0.0591 divided by N. N in the sense we have to substitute 2. Okay, because 2 electrons. Log of Zn. sorry, here I am going to writing anode. Okay, what is the anode? Mg2 plus, and bottom side, what is the cathode? This is Cu2 plus. Okay, according to this, I am going to be writing the equations here. See what happening. First one, E cell as it is. E cell in the sense, whatever the Cu plus 2 divided by Zn plus, sorry, not Zn, here magnesium. Okay, the cathode is magnesium. We are derived so many times for galvanic, hence we are writing that. Okay, now this is magnesium equals to E naught, sir. E naught in the sense, E naught of, right down here, Cu2 plus Cu minus E naught of Mg2 plus Mg. Okay, minus, again take the minus 0.0591 divided by N log of, write the given concentrations here. What is the concentration for magnesium? 0.01. What is the concentration for this copper? This is 1. Okay, this is the first method. Now what I am going to be doing, I am writing here, I am substituting the values here. Okay, this is the E cell value substitute. Copper का क्या है बेटा? 0.34 minus of minus 2.37. Okay, 0.0591 divided by N, nothing but 2, because 2 number of moles of electron is transferring how much? 2. Okay, and law of, instead of writing this 0.01, I am writing in the form of 10 power minus, tell me, 2 digits I have to check, 10 power minus 2. Okay, 10 power minus 2. I can write here, see simply 10 power minus 2. Okay, now see here what happening. Let's calculate E cell, simplifying this one. This is what value, 0.34 plus what happening, tell me, 2.71. 2.71 minus 0.0591 divided to 2. This is a form of what? Log A power B. I can write B log A. Okay, B log A. I am writing here minus 2 log 10. Log 10. Log 10 value is how much? Log 10 base 10 is 1. Okay. Now see here, 2.71. This 2 get cancelled. Okay. And whatever the value will be there, this is became what? Plus. Okay, this is minus into minus. Here we are having a C of this is a minus. Okay, 2 get cancelled. 2 into 2, minus into minus, plus 0.0591. Log 10 is 1. This value is 1. And calculate. We are going to be getting the E cell value. What is this value? Write down 2.7691 volt. Okay. This is what is the E cell at 298 Kelvin. Okay, 298 comes under where nothing but we already derived. This is final expression only. This is 2.30 RT divided by LF is there. F we are substituted 96,500. That is standard value. Okay, and we are having R, nothing but universal gas constant is 8.314. We are derived in the last process. Just I am taking final expression. Okay, after substituting those values, we are getting this equation. If I am going to substituting this all values, I will get this equation. कुछ भी नहीं है, very simple. One more time explaining. See, we are having cell 4. This reaction I am going to be writing first. Okay. First we have to mention electrode reactions. Okay, this is a cell representation. I converted this one into the, okay, at anode magnesium plus Mg plus 2 electron is releasing. At a cathode reduction takes place. After combining these two, how we have to write? Write left side at right side. Write right side at right side. Okay, Mg plus Mg Cu plus 2 electron get cancelled. Mg2 plus and C. This is a writing. Okay, is already your standard electrode potential. I am writing first. This is equation. Put all this value in this one and we are integrating. Just some students are going to be lacking at this taking here. Okay, 0.01 nothing but 10 power minus 2. Okay, 2 digits we have to shift to decimals. This 10 power I can write 10 power minus 2. And one more important value is log A power B. Okay, this is standard logarithm. These are the formulas. उसको हम क्या लिख सकते हैं? B log A. Okay, after the substituting this log PA, okay, we are going to getting log 10. Okay, 10 nothing but this is a 1 value. Okay, after substituting we are getting this one. This is what one more important problem. This type of problems are asked in final examinations, and the CET point also these are going to come. Okay, take down first or take screenshot. 1 2. Okay, students, now after the completion of the some problems on the Nernst equation, which is belongs to the half cell and the one other one is a complete cell, or I can say that is a galvanic cell, or calculating of cell potential by Nernst equation, we are having another important the expression or derivation, that is a equilibrium constant from Nernst equation. Okay, we can going to be derive a Nernst equation for the equilibrium constant. What is that equilibrium constant? Okay, why we are going to be deriving this one, let we are going to see. Okay, first of all, I am considering a galvanic cell. Okay, the galvanic cell, already you know, when we have to say that galvanic or Daniel cell under the process, when current is going to be taken from that. Okay, whenever we are going to be taking the current or electricity from the Daniel cell, we have to tell that at that same time the galvanic cell under the process. Okay, what the reactions are going to be happening here? See, at a cathode, these are going to be Zn gives rise to Zn 2 plus 2 electrons, and this at a cathode. Okay, at cathode Cu plus 2 plus 2 electrons gives rise to Cu. This is solid. Okay, like we are going to be getting the reaction. At final, I can say Zn plus Cu 2 plus, this is aqueous, this is solid, and we are going to get here Zn 2 plus, this is aqueous, and Cu, this is solid. Okay, this is a cell reactions what is going to be happening at the